As you can tell, it's going to be slightly different this week because I was told we can't do Zoom meetings anymore. I'm going to try to find a alternative. We might be doing Google Chats or something, but I'll let you know. So in the meantime, we'll be making these YouTube videos, and then just email me any questions through email. Since it's week 2, this is kind of how I feel. I think it's exciting. We're trying something new, and you're all probably feeling like that by now. So. Alright, so what is week 2 going to be about? It's going to be about Newton's second law. As you remember from week 1, Newton's first law is all about what happens when the forces are balanced. And when the forces are balanced, the object will not change its motion. So if the object is not moving, it will remain not moving. If the object is already moving, then it will stay moving. So the speed does not change in Newton's first law. In Newton's second law, it explains what happens when the forces are not balanced. So that means you either have too much force in one direction or too much force in the other direction. And so in Newton's second law, as you can see here, what happens is if you have an unbalanced force, it'll either speed up or slow down. And so the acceleration of an object by force is directly proportional to the force and inversely proportional to the mass of the object, which means two things. It will determine how fast it speeds up. The size of the force and the mass of the object. And so another way to think of this is big and small. So if you have something that is really big, it either needs a lot of force to speed it up or it will be really slow to speed up. That makes a lot of sense. I mean, like a train has a lot of mass, so you need a lot of force to speed it up. Whereas a skateboard doesn't have very much mass, so you can use a little bit of force to speed it up, or if you use a lot of force, it'll speed up really quickly. So once again, the force is important and the mass is important. We can see this in the simulation. So if we go to the simulation and we go to the motion one, let's say we have a box, and let's look at our values. Our box has 50 kilograms, and so if you apply a force, an unbalanced force, you'll see it starts speeding up. So it's already at 3 meters per second, right? It's already at 8 meters per second, and then 10 meters per second. So as you can see, it's speeding up, and it's going to continue speeding up because there's an unbalanced force. But what happens if we use more mass? So instead of a box, let's put a refrigerator, and let's put a man on top of the refrigerator. All right, so we have 80 and 200, which is a lot more than 50. We're going to apply the same force, 50. You'll notice that the speed is still speeding up, but the acceleration is a lot slower. So even though it is going faster, it's speeding up a lot slower than otherwise. And the reason why is because you have more mass. So once again, big and small. So the bigger the mass, the slower it will speed up. Okay. We can do the same thing with, let's put the gift. We can do the same thing with different forces then. So let's try 50 again. Okay. And as you can tell, it speeds up pretty quickly. Alright. But what if we increase the force? So instead of 50, let's go to 200. You'll see that it accelerates really quickly. So the bigger the force, the faster it speeds up, the higher the acceleration. Okay? So that's pretty useful. Right. Once again, big and small. Okay. Here's a very famous equation. It's called acceleration is equal to force divided by mass. So the acceleration depends on two things: the force that you apply and the mass of the object. If the force is bigger, the acceleration will also get bigger. That's what it means by directly proportional. If the mass is bigger, then the acceleration actually gets smaller, because if the mass gets bigger, then this whole number gets smaller. So that's the inversely proportional to the mass. And that makes sense. Once again, the more force you make, the more acceleration. The more mass you have, the less acceleration. Okay. We were going to do a couple activities in class about robots. These are robots about mass and motors and stuff like that. So for this one, we just, I guess, have to imagine it. What would happen if you had more mass or less mass? You have the same number of motors. Which one would speed up faster? Well, let's think about it. If you have two robots exactly the same with the same number of motors, then the more mass one would speed up slower. Yeah, the one with less mass, the lighter one, the less mass one will speed up faster. How do we see this in real life? Well, we see it when we talk about, like I said, the train and the skateboard. Okay? Second one, let's say you had the same amount of mass, but one of them had 2 motors, one of them had 4 motors. Well, which one will speed up faster? Well, this is pretty obvious. The one with 4 motors will speed up faster because it has more force. Okay? What do we see this in real life? If you know anything about engines, a V8 is a lot more powerful than a V6. If you've played Mario Kart, the 150cc is a lot faster than the 50cc because it has a bigger engine size and stuff like that. Okay. Oh, okay. And then what we do then is we look at force diagrams. So when you start counting up the forces, you start seeing that sometimes the forces are balanced, in this case 300 this way, 300 this way, in which case no one wins. Okay? But if you have an unbalanced force, 400 this way, 300 this way, then all of them will move this way because the unbalanced force is going that way. Same with the bird diving. So the bird will use gravity and to dive, but then it has some air resistance to slow it down, right? Or even a rocket ship. This is the rocket ship will push the air below it, and then it'll go up and try to break the force of gravity that's pulling down. So we have unbalanced forces. And so the last thing we'll talk about today is page 64. Page 64 is the worksheet. And so the worksheet is all about these force diagrams. So to get to that, you go to your Google Drive, and you should have a form just like this, a worksheet just like this. And what I did was I created a few scenarios. So let's say the first one, you have Samurai Jack. He is jumping at a force of 1,000 newtons. Gravity is pulling him down at 700 newtons. So this is obviously unbalanced. So the resultant force is going to be 300 newtons up. And so if there's 300 newtons up, what will happen to Samurai Jack? He will jump up. Right? The second one, we have a moose. The gravity is pushing down at 3,500 newtons, and the water is pushing up at 3,500 newtons. Okay? And so luckily, this is a balanced force, which means that the canoe will float. So your challenge now is to go through the rest of these questions and see if you can answer it based on the balanced or unbalanced forces. All right, so good luck. I'll see you guys tomorrow. Bye.